In previous episodes, I have talked about how to automatically mask the localized protein DNA complexes and how to identify the type of protein DNA complexes and how to add them to a new particle set with added positional context. Now, in this video, I'm going to introduce you a new script that I wrote that streamline this process because I combine all three methods. So this allows me to not only mask the protein DNA complexes, but also add them to a particle set with the added positional context, all in one click. So after I have the new particle set, I can continue with advanced particle analysis, such as performing particle classification. Now, previously, I have done this analysis, but without particle position information. With the new particle set, we can perform the same analysis, but with the particle position information as well. Now, since we are trying to include the position information that can only be recorded inside Region Inspector, so let's open up Region Inspector. Here I'm showing you an example on how to use the new script. So we have a complicated protein DNA complex here, and there could be multiple ways on how to dissect this molecule. And one way is that it's two DNA molecules that's linked at the end here. As you see, there's a little bit of extension of this DNA, and that could be the end of this DNA molecule, and that could be another DNA molecule that's just hides beneath this joint complex, right? So basically, these two DNA molecules, they are linked at the end. So that's one way to dissect that. The other way to dissect that is this is just only one piece of DNA molecule. So let's use the first way of dissection to analyze this molecule for our demo purpose. So let's first click this DNA molecule, and so it's well traced first at this point. And so let's just first analyze its positions of the complex. Let's click the profile called Find Peaks and Spans, which I showcased in a previous video. So let's click that, and this would record its positions and also its spans of the complex. Now, if you're already familiar with this process, you can skip this part. And for those who are not familiar with this single molecule analysis on protein DNA complex, you can check my long form video on protein DNA on single molecule analysis on protein DNA complex. So we analyze this position information, and you notice that I also analyze the protein DNA complex type. It's called PD type here. So we have one specific complex labeled as SP, and that's this complex, and another complex is non-specific complex, and that one. So and for my complex, right, specific complex means it's binding to a specific structure or sequence that we already know beforehand, right? Because we engineer these DNA molecules, so I know where the structure is. So that's how I can calculate based on the position of the complex, right? So I can determine what type the complex is, and this kind of calculation is enabled by using a script as well, and I mentioned that in a previous video, and you can check that out in the link below the video description. So that's this script. I trace post-process PD type. So I already checked that. And that's why after I record my positions, it also calculates the type of the protein DNA for me. So after I've done that, let's go ahead and measure the particle matrix of these two complexes. So I'm going to crop these particle out. And I do the same for the second particle. Now let's add the information to the first particle, and then let's click the second one and add that to the second particle. Let's see if that's well or not. Yeah, I think it's not added to this one. Yeah, here we go. So yeah, sometimes you may accidentally drag these polygons around. It doesn't matter. The region is still restricted in the complexes that were previously drawn. So if you uncheck the transparency, that's exactly what we want, right? So, okay, let's remove all the region of interests, and then we can measure some angles and add some angle information for these complexes. So the angle would measure the degree of DNA bending. Let's add a secondary one here. Yeah. Add the angle. Okay. Yeah, so we have, yeah, I also want to label its conformation. Now the first one, it's okay. It's on a specific site with some kind of DNA bending. And the second one, I think it's near the end. So I'll call it end binding. And it's also linking two DNA together. So I may call it link, right? With a question mark because I'm not sure. It could be just one piece of DNA. So that's that. So that's the additional confirmation information that I can manually add. Now, if you want to add this column, you can simply type here and add your own column. So yeah, so now I'm going to show you the script that I'm describing for today's video. So in order to use the script, you have to record the XY location of the protein complex. And in order to enable that recording, you have to right click. Right, it's already recorded for S. Now, if it's not there, right, if somehow you have not enabled XY recording, it won't be there. So now to enable XY recording, you click the trace and you select options. Then you check the XY here. That's how you enable XY recording. So you have the XY location, and they also want to make sure that the DNA is masked. So yeah, usually it's masked. So in case it's not, then the script won't work. So let's uncheck the transparency to make sure the DNA is masked. It is. All right, so we have everything ready. So so the script can be added under. So if you right click the table, and then under custom operation, you can find this script. It's called mask protein DNA from XY. Okay, and there's also another one, interactive version. Now the first one is like with the parameters already predefined. You can also edit the parameters in the script file, and I'm going to show you later on the what's inside the script file And now if you want to change the parameters on the fly, now you can just use the interactive version. It will open up a dialog box where you can change the parameters. Now, if you cannot find these two profiles, you can click Load Profile. You can find them under the Scripts folder inside the Image Matrix Programs folder. So, so this script is a extended version from the original script I wrote for the automated masking of protein DNA complex, and you can find that in the link below. And that's another video. So, all right, so let's just click this and see what it does. So what it does is it uses the existing information, right? It automatically masks the protein DNA complex and add them to a particle set, right? So now you can choose which particle set you want to add to. And we already talked about the particle set feature in a previous video. And if you missed that, you can check that out in the video description. So now we have all the information about this particle, right? Like we have two particles here. So because I have two rows here, and so in the first particle, see that the table is the same as the first row in this records table. So I have the specific complex that's there, and the 110 degree, that's the angle there. And that's our complex 1. And let's go to complex 2. Yeah, complex 1 is this small one. The complex 2 is this big one. And you notice that the complex we also included some part of the DNA arms. And that's what I want, because I want to classify the DNA bending, right? So that's why I need to include the DNA arms. So now the particle 2, we have the confirmation that that's what I just wrote there. It's not specific about it. So it has all the information about its usual parameters, such as the volume, area, stuff like that. But it also has the information, like namely the position information, and also its confirmation information, the complex type information. So it has all the information we need. So that's very useful when we later on do particle classification. So we will know more information about the particles, such as its position on the DNA, right, and also its complex type. So then we want to add them to a particle set, and now you cannot add to the default set. Just pick a set that you want to add. Just pick a set that's not the set you're currently viewing. So because I'm currently viewing the images from my default set, I cannot add to the default set. So in this case, I simply added the pretty complex type. I already made that set, right? If you want to make a new set, just click new and enter the name of your set. And now I'm just adding to a PD complex set. I can click add. That would do that. I think in this example, I already added this to my set, so I'm not going to do it again. So just click add. It will be in your new set. So yeah, let's go back to my main image. Let me show you the set that I already added. So this is the image that we just we have seen this complex. Now we are at the retrace particle set, and not the default. That's a mistake I mentioned earlier. So now let's go back to the PD complex set. Now I'm the PD complex set, and you can see the particles, the localized protein-DNA particles, right? Let's zoom out, and you can see the 108 particles I analyzed. Now this is all the localized protein-DNA complex. If you zoom in and see that, yeah, these are all the localized protein-DNA complexes. Let's go back to let's analyze in the height retrace channel. And you see that's all my localized protein DNA complexes. All right, let's see what's beneath the hood of the script. Let's first open the script. Now we are looking at the script. Let's see what are the parameters. So this script is called mask protein DNA from XY. And now the first user parameter is the mask option. We use a circle, but I can also use a box. So circle means that we try to crop. How do we crop our protein DNA complex? And if you see earlier, let me do it again, just so you can see them better. So as you see, it's kind of circular around the edges. Like that's what I mean by using the circle option. Like the DNA arms, they're curved. So we use it because we use a circle to crop this protein DNA complex. That we crop them from the center of the protein mask. So that's that. And you can also use a box option. I think circle is more symmetrical. That's the parameter I prefer. And now the second parameter is whether you use manual mask or not for the DNA. And there's three options, right? You can use the manual mask. Basically, you can set your mask parameter inside region inspector, your mask threshold, and use that threshold when we do the DNA masking, right? But you can also use a set a mask threshold here. So this is like you can use a fixed value, right? So it doesn't care about what the program sets the value, just use the fixed value here, right? That's the second option. And the third option is this option. Right now, I'm just using the third option, right? And that's when you want to use AutoMask to calculate the mask threshold. That's what I'm using. I'm using AutoMask for my DNA mask. Now then, we're looking at the third parameter. This is the box size. Now this is only applicable to the when we use the box option for our mask. Now because we're using circle, this does not apply. You can simply ignore that. Now this one would concern the circular option, right? So this is the radii of our circular mask, and there are two ways to determine the radii. So you can either use the fixed option, just uncomment this line, and then set the number you want, or you can use the auto radii calculation. So the auto calculation is based on the size of the protein complex. So basically once you crop, it's based on so when we analyze our protein DNA complex, so this is the one that when we use the region of interest tool, we crop these complexes, right? We take measurements, and so we have an area, right? Parameter, that's the area, right? So basically what the script does, it takes the area, right, to calculate the radii. So right, based on the PD area size. From the existing area column. So they use that area, right, to automatically calculate the radii. And then so this tells the next parameter says what's the ratio of the PD crop area relative to the area. So we have the area, right, and we want to say the crop size, because we want to crop some of the DNA and not just the protein, right? If you just say the area to the ratio is 1, then you simply just crop the protein itself, right? But want more than that, we also want to extend the mask to include some of the DNA arms. That's why I'm set this to about 4. So 4 times the area, which basically means double the size of the radii, right? So that's about twice in terms of radii of compared to the regional size of the protein complex. Now, if you see here, so the regional radii is probably about like from the center to the edges, right? That's probably the regional radii. Now it's double that, right? That's why we have a larger circle, right? It goes to include some of the DNA arms. So that's that, and then and we have the volume filter, right? Whether we want to filter the protein complex by volume or not. Here it says no. I think, yeah, I think that this one apply. Yeah, we can apply a range of the volume filter. Leave empty if you don't want to filter by volume. I think this means like it's empty. So this means like we don't want to filter by volume, right? So for sometimes the DNA protein complex is too small. They could be just protein fragments, right? They're not real proteins. So we don't want that, right? We don't want to include them in the particle set. Now, in that case, you can set a filter in the volume just to define the, I think it's the minimum volume essentially. To set a minimum volume here, so below which, right, the proteins won't be counted, right? They're counted as garbage, right? Trash. But in this case, I'm just including everything, right? Even the smaller ones. So that's that. And then, yeah, we don't need to care about the rest. That's just the code that I use to calculate all this stuff. So these are the parameters that the users care about or need to change for their script. And so once you have these parameters predefined, you can simply run this script, right? By simply right-click these and click this profile, right? Now, if you want to use the interactive version, right, and so basically specify your parameters every time you add them to the particle set, you can simply click the interactive version. So what it does is just basically pop up the parameters for you. You can set these parameters that we just saw and click OK. Now you have to do this every single time, and that's not when I'm not preferring this. Because we don't actually change these parameters much, if at all, for our data set. For a specific particular data set, right? It usually remains the same. So I usually just set my parameters in this profile and then just click the non-interactive version of my profile. If you want to see how well the script does, you can go back to the molecule and turn off the transparency. And you can see the script does a pretty good job in masking the protein DNA complexes. So this is a very powerful feature that it allows you to process the protein DNA complexes in bulk and add them to the particle set with their positional context, right? Instead of doing add them to the set one by one, right, I can simply use the script to automate this process. So that's pretty much for today's video. Thanks for watching, and I'll see you next time.